Hello, everyone, and thank you for joining us for another episode of the Saddlefit for Life webinar. Today, we'll be talking about the transitional vertebrae, which will be presented by Dr. Catalina Thiersen in conjunction with the Helen Alana Davies Research Project.
Hi all, welcome with us. I have to give some credit to Helen Davies and the Equine Research Project that I work with. And we have horses donated to the project, so I thank Helen for all her dedication and everybody else that's involved and supports the project. Thank Jochen and Saddlefit for Life and Sonia for supporting us and working with us. So what I'm showing you today is a transitional vertebrae. This is what we've got on the screen currently. But what I really want everybody to understand at this point is that when we look at vertebrae, a lot of people are under the impression that your processes that are transverse processes, so they head out to the side, are only found on your lumbar vertebrae. This is not true. Your thoracic vertebrae and your cervical vertebrae have transverse processes. They're much smaller and they will be affected by weight bearing or changes in weight bearing. I will show more examples of that, but I'm going to start with what we've got on the screen is a lumbar vertebrae that is actually in between, so it's transitional. Half of it actually wants to bear a rib and wants to act like a thoracic vertebrae. The other half of it is a proper lumbar vertebrae. A lot of horses have this, and a lot of horses have this only on one side. And if we go into the weight-bearing portion of the actual spine, where the one vertebrae will be articulating with the other, because the spine is like a spring moving together, you will see that the actual joint here is a different shape to the joint on that side. So this horse's spine is going to be very delicate in this area, and this will be the area directly behind the saddle. This is directly behind where the last rib sits, where the actual end of the panel bearing portion of the horse's spine would be. You would then find this type of vertebrae in some horses. These horses will be largely intolerant to the square numbness or saddle pads that we use quite fashionably these days, because it will irritate on this extra extension that's actually a free rib, because it does not attach to the actual rib cage. It's not stabilized by the cartilage. It is just hanging in the air. And that saddle pad will actually rub on the end here, causing that horse to be quite uncomfortable and quite unhappy. The other thing that we see is if the saddle then becomes a little bit too long and you're actually going that half inch or even an inch over the actual rib cage, and you're coming onto this first lumbar vertebrae that is now an in-between and already reasonably unstable, because the two joints that you're looking at are different shapes and they will not actually sit flush and they will not sit stable. And you won't see this from the outside because the horse has got quite a large amount of muscle over the top. You're going to find that every time that rider rises or sits down and that panel's a little bit long, you're going to get an instability and a movement up and down here, which eventually is going to be quite painful for this horse. And you can then have a horse that's bucking, behaving quite badly, and it's not a naughty horse, but a horse that is in excessive discomfort over time. And that is the point at which you start seeing very much this tiny little outgrowth here that you see here on the side would start happening to try and stabilize this joint. And eventually, given enough time and enough instability, that will fuse. So the other thing that I wanted to take a moment to show everybody is that there's a nice canal here on either side of the actual, what we call the body of the vertebrae. And that's where the nerve comes out. In the center here, we've got where the actual spinal cord comes through. This sits flush with another vertebral body. But here, a nerve root will come through. And you can see if there's movement up and down here, that can be quite uncomfortable and quite nasty for a horse to actually experience. Here we have a second photograph that I'm demonstrating for you so that we can have a look here. These are normal lumbar vertebrae in a sense, in that they have normal size transverse processes. This horse has quite a lot to tell us, but I'll get into all of that. So the first thing I want you to notice is we've got another transitional vertebrae here, where the lumbar vertebra is only half of a lumbar vertebra. We're also looking at the skeleton from underneath. So where the previous picture we were looking end on at the vertebra, we are now looking at its underneath. So you can see now when it's put together with the spine, you'll get a rubbing between this transverse process and this want-to-be rib on the half of the transitional process. So you can see any pressure, any instability here will cause this horse some major discomfort. It's also going to cause rubbing between these two over here. And over time, the spine's going to try and stabilize itself, which is what the skeleton just wants, a stable environment. So it is just going to try and build an extra bit of bone to create a solid structure. So less movement and less pain actually is incurred. Now, the other thing I want to take just a second to point out to you, because I pointed out on the other one where the nerves come off. Those nerves come out through holes at the bottom here. So this area on a spine needs to remain clear to keep clear of the nerves. Else you're going to get disability in terms of muscle wastage. You're going to get dysfunction in terms of a leg that or a portion of the horse that cannot move in its normal way because the signal's not traveling through. And you're going to get pain. And it's a very different type of pain to a sprain or a direct acute injury. It's the kind of pain that nags and continues and actually gets oversensitized to the point where even if you just touch the skin over that area, you're going to get a reaction. So it just demonstrates to you how important open space is where nerves are actually needing to run through the body. Right. So when this vertebra that I showed you in the previous one, now in a skeleton and a full spine like this, is not aligned because you saw the facet joints that didn't actually join up properly because the one's a different shape to the other one. You're going to start getting instability here. That is going to keep the whole thing unstable all the way back. And what's going to happen is you get a slightly skew alignment in the second last lumbar vertebrae. And now you've got overlapping of transverse processes. And that is going to rub and rub and rub. And this horse would maybe disunite in the canter, maybe not want to canter on one side, maybe won't be one-sided and not want to move in a circle on the other side. And it could be avoided by making things just a little bit shorter for this horse before the major changes happen, so that the saddle and the rider don't actually cross this line before this transitional vertebrae. Because if it does, you're going to get a spine that changes very similar to this particular spine that we see here. Another thing that I want to point out on this particular specimen is where you're starting to get fusing here, and you get the overlapping of the spinous of the transverse processes. That instability is then less for these two vertebrae, but you've still got moving forward, two more that are unstable. So you start seeing little spurs on the side here where these two are now trying to fuse because the horse wants to be stable. And it will eventually form a bridge of bone underneath here to fuse the entire spine. And it will continue to do so on the vertebrae towards the front of the horse. Now we see these changes, and we've seen them in the collection and in the research in American saddlers, horses with too long panels for the actual spine. We've seen it in saddles that are too far back, where they're actually touching on the lumbar vertebrae. And more often in horses with the transitional vertebrae, where the transitional vertebra has been counted as a last rib instead of just a transitional vertebrae, and they've made a saddle slightly longer because the horse appeared to have a longer back and things appeared to be out of proportion. I think of one particular situation where I've seen a Frisian fitted with a saddle that the rider needed a 17-inch saddle. The horse could probably have benefited from a 17-inch saddle. The horse ended up in a 17.5-inch saddle because the saddle fitter felt it looked out of proportion with a 17-inch saddle, where the horse's actual panel bearing size on her back was in fact a 17-inch panel size. So these things, to me, in the skeletons that we do, really indicate that we need to think, when we put a saddle on a horse, about where they sit, how they sit, and what they touch. And we need a clear indication with a professional that actually measures the actual thorax of the horse, which is the rib cage of the horse, and make sure on both sides of the horse that it is similar, to avoid this kind of thing. And that what we see in the American saddlers, where they sit so far back on the horses, we see these changes, and that indicates that we don't want weight beyond a portion where the horse really shouldn't be carrying weight. So I've got another slide here just to indicate for everybody different types of how different transitional vertebrae can look in some of the different skeletons that we've done. And here's the classic one that we've seen before. And I'm going to just go over it again, because you've seen the facet joints from the back of it, from the back of the vertebra. This is what they look like at the front. They're two little wings at the front here. So now you can see those have to rest on the back wings in order to create stability that we've been talking about. And if they're not shaped 100%, you can see that even the cord that runs just underneath the spinous process, which is this top process that you have, even the cord can be influenced by it. Now, something we've not touched on, and I'm going to touch on now, is every spinal nerve that comes off has what we call a ventral or bottom branch on both sides, and a top branch on both sides. So the whole of the canal where the top branch comes out sits right here. It comes right through that little hole that we find here. So that starts closing up. We've got another nerve problem that kicks in. And it's going to give the same problems as the bottom one will. So any instability rubbing on those two at the top here is again going to cause us trouble. Here we see, so if we look at this as the standard transitional vertebra that we saw in the very first picture, this is a different type. It's slightly shorter. It still is transitional because the direction that you're pointing in and the one is slightly longer than the other side. It will cause less trouble than this guy will. And then in the third place, we've got a very interesting one, because this is one where we don't have a normal transverse process on the other side, but we've got this very long transitional transverse process on the one side. And again, this horse will have all sorts of problems if anything, even just a numna or saddle pad touches that vertebra, because it'll be super sensitive. And whilst I'm here, there's a very interesting thing to point out on these two vertebrae that we're looking at and this particular horse. And that also has to do with, this horse has probably had either a rider that was particularly unstable in the saddle, or someone that sat a little bit too far back, or had a little bit too much pressure on the spine behind where the saddle should actually end, behind the thoracic spine, but onto the lumbar spine. So here we start seeing changes in the top canal where the spinal cord should send its spinal nerves off. And you start seeing a little hook over there that actually can start eating away at that nerve, causing it to swell. And I actually, sort of in research, we're looking at it at the moment, that how much of our lameness is actually coming from the spine, in fact, being irritated and only manifesting in the legs. And we're actually starting to look for the legs, for the problem in the legs, where a lot of times I think there's a lot of sort of back involvement. And I think saddles are not considered in when we're looking at a horse with a lameness. And there's always the danger of, relying too much on what we see at the time when the horse is dead lame to where the actual cause of the lameness started. And I think we underestimate how much saddles can actually, and rider biomechanics can influence a horse's sort of strides, its length of stride, its placement of its feet. And over time, we are going to see degenerative changes because it's not being used in a correct manner. But yeah, this is a very nice example of a horse that actually had too much pressure in this region, because the changes that we're seeing on the edges here, and the fact that this horse is trying really hard, or the horse's body was trying really hard to actually close the gap between the two vertebrae to make it stable. Okay, so here we've got a sacrum. We have our last lumbar vertebra. So that's L7, L6, L5, L4, L3, L2, and L1 would have been in front here. And this is a very interesting horse because this transitional vertebra is actually at the level of 2, which is the second lumbar vertebra, which means the first lumbar vertebra would have been normal, and the second one is abnormal. And although this horse is not, it's not an indication of a poorly fitting saddle or a poorly fitting numna at this point, it does show us that we can have an abnormality that happens further back in the horse, and we need to be aware of it. This horse did develop other problems due to other things in its life, but it does show us that we can see this transitional vertebra further back, just to point that out. In terms of this particular horse, in terms of the problems that we can see, this particular horse would have had a slightly rotated pelvis, and there are a lot of arguments for and against why that could have been. But that rotated pelvis changed an alignment in the transverse process over here, which then makes it overlap and bridge on the one anterior or cranially to it. That is going to mean that this horse, A, under saddle, is not going to be able to round its back as much as it should behind the saddle. The other thing that it's going to lead to in this horse is it's going to lead to one-sidedness, because this one side is going to, which in this horse would have been its right side, is going to hurt more in certain positions than in others. And even just grazing, this horse would have had a little bit of discomfort. And I think horses like this, when we look at the skeletons like this, they do highlight for us that when we evaluate a horse, we need to take into account that a skeleton might not allow it to do certain things. And they certainly teach us something in terms of that. This horse actually did jump quite well in his life, but was unsound later in his life. Here we've got another picture of a transitional vertebrae taken from the top. This particular picture it gives you an idea of when we look at a normal spine, a normal transverse process, we are looking at a very small structure compared to the transitional portion that is actually the extension, that is almost like a rib that comes out on the other side. And a little bit away from what a transitional vertebra means in terms of saddle fitting and in terms of a horse's abilities and things. In this, you can see the difference quite clearly between how the structure works in the portion of the horse that is bearing the panel and the weight of the rider versus further back or behind the saddle in the lumbar region. This would be what your lumbar region in a normal horse would look like. If you look at the portion closest to the vertebra over here, that would be the portion of the thoracic vertebra that would normally bear a saddle panel. And you can see the structure is slightly stronger because of the curvature and because of the thickness of the bone. The bone over here is quite thin, and it is basically there for the attachment to muscle, where this is a far stronger structure. It's a good time to point out why and where the panels of a saddle should be and where the weight of the rider should be. There is less chance of putting pressure on this portion and causing a movement here than there is by putting pressure on this and causing a movement in the vertebral body. And like I described earlier, any vertebral body movement causes an instability not only around the spinal cord, but the spinal nerves and over the facet joints. And when we have that kind of instability, we get a fusion within the spine, which leads to all sorts of other problems for the horse and inevitably for its rider. So further to what we've discussed in terms of transitional vertebrae and changes that we see in the spine with saddle panels and rider weight and biomechanics, we'll be looking at forces that will force a spine into kissing spine even when the horse does not have kissing spine. We will look at how the vertebrae align with each other, how your thoracic vertebrae function underneath the saddle panel, and how the ribs actually create quite a nice spring to support the saddle and the rider. We'll also look at the horse's freedom to breathe whilst being worked, influenced by how the vertebrae are aligned, also how the nerves are aligned. And we'll be looking at further mechanics that causes a misalignment, but also permanent changes and damage within spines. Then we'll look at how transverse processes are damaged and how easily they can actually break, and what the remedies could potentially be, if there are any, for horses with some of the changes.